Yeah, I'll post it. I'll post the video online. Okay, so Catherine and Owen or whoever else wants to watch it this weekend.
They're fine. Wow.
All right.
They're perfect.
To be honest with you, I'm not being mean, but if you can't do this problem, you've got to really bust your butt this weekend because this is a pretty easy problem. Now, I'm showing you two ways you can solve it. First way, you could have just done it really simple. Just say summation of forces equal mass times acceleration. The only force you have here is the 16. There's no friction here. So you could just go summation of force equal mass times acceleration. 16 is equal to total mass, which is 8. Find your acceleration, 2 meters per second squared. That's how you would have gotten acceleration. And you can do this with any type of problem. Now, if there's friction involved, you have to add the friction in.
Wait, so all you have to do in the problem is take the force that it shows, so 16, and set it equal to both the masses added together.
If it's a problem like this with no friction, yes. Okay. Now, the second thing you had to do, all you had to do was draw a free body diagram of the one block. So all I'm looking for on this one is what is the force right here? What is the 2 pushing on the 6 and 6 pushing on the 2? So all I'm going to do is draw a free body diagram of this guy right here. And I did that, and the only force I have is, the only force it has is the force that 2 is pushing on the 6. So just summation of forces equals mass times acceleration. The only force you have is that one. Force of 2 onto the 6 is equal to mass times acceleration you got here. And you get 12, and that's it, and you're done. Does that make sense? Hope you find that real easy. Well, I'm just saying that this one is easy. But if you're missing something, it's okay. I mean, it's no big deal. You can recover this weekend. Okay, that's scenario 1. Now, scenario 2, if you don't like that approach, you can draw 2 free body diagrams. So you draw a free body diagram. This is the free body diagram of the 2 kilogram object. So the forces that have the force of 6 is pushing onto the 2. I have the force of 16, and you don't really need these because you don't have friction, right? You don't necessarily, they don't really come into the problem. So all you have to do here is summation of forces in x is equal to mass times acceleration. You'll get minus the force, the 6 onto the 2, plus 16 is equal to 2a, right? There's your one equation. Everybody see where I got that? Okay. Come down the next one. The force you have there, same thing. Summation of forces is equal to mass times acceleration. Force of 2 onto the 6 must equal to 6a, right? Okay. So now you have that equation. Take that guy right there and plug it right back in. Take this right here and plug it right back in there, and you solve the problem. So then you got minus 6a plus 16 is equal to 2a. 16 is equal to 8a. A is equal to 2. That make sense? And then you put it back in right there. Just plug it right in, and boom, 12, and you're done. Does that make sense? Yeah. Okay. The next ones I'm going to kind of let you work in your groups. Now you work. Don't come up here and ask me how to do it. Try to work in your groups. Figure it out. The first one's not that hard. This one, you have a 44 Newton force being pushed here. There's no friction along this surface here. However, there will be friction here. There's only going to be friction in one spot between the 2 and the 9 right here. There's no friction here. Here's what I want you to do. Tell me what the acceleration is of each block. Okay? Tell me what the force is between 5 and 9, between 9 and 6, between 2 and 9, and then tell me what the frictional force has to be to keep this object moving to the right, accelerating to the right. I promise it's not as... You guys can do this problem. I mean, the acceleration you should get just seconds, right? Because you have no friction. There's no friction here. This friction here is not going to count. Uh-huh.
You should also find acceleration easily when there is a coefficient of friction.
Yeah, I can show you that. Uh-huh.
But after you find acceleration, do you have to do a force diagram for all of them still on the clock?
I would. You could, if you want to make your life a little easier, you could do a free diagram of this one, and you could get this force and this force. And you could leave the 9 alone.
But then you also have to do it for the 2?
Yeah, you have to do it for the 2 also, yes.
Well, you have to do the 9 for the 2, so you can do the whole problem without making force diagram for the 9.
You can, yeah, you could, yeah. And if you're struggling, don't go home and not study. Please go home and work a bunch of problems over and over again so you know what you're doing. Because you will fall on your face in this test. It's not hard. It's just what we're doing in class. If you can't do the problems we're doing in class, then you're not going to magically show up Monday and do the problem. That's okay. I mean, you're going to be fine if you can fix it this weekend. You'll be fine. No. Yeah, no. I really don't like textbooks.
I have a stack of textbooks that just constant in my room.
There's really not a good physics textbook for first year physics students. Not for governor school kids. Because they're either way too easy or way too hard.
You already done these problems after all?
No. I can do it pretty quickly, I think.
Is that what you do?
Wait, if you drop free diagram now, do you take the 2, multiply that by 9.8 and have that force going down?
Oh, 9.8, it can only, yes.
So instead of just the 9 in gravity would be the 2 and the 9 in gravity, so that'd be the force.
What are we talking about here?
Yeah. Alright, we good.
Okay. So hopefully everyone got acceleration as 2, right?
Wait, which way did you say you want the friction to go? Like, keep it moving to the right?
You tell me.
No, you say you want to keep moving to the right?
Yes.
Okay.
Well, I mean, if it's accelerate right, friction here has got to go to the right on 2.
So they're all accelerating too. So that's for the what?
What did I do?
Wait, Judge Holt,
Uh-huh.
are the G forces here? Are those frictional forces or?
Oh, no, vertical. That's only vertical right now. Sorry. That's 2 onto the 9 vertical.
The dots.
Yeah, the dots, yes. This is in the Y direction only first. Right? The force of 2 onto the 9 is pushing down,
Yeah.
and the 9's pushing back up. Now I'll do the
Those
other.
are, okay.
I'll say those are the X direction, X direction. How about that? Now let's do... I'm going to write these separately. What did anybody get for this one? Anybody get this one?
34.
What'd you? Anybody get 34?
Yeah.
Okay.
12.
And 12, right?
Yeah.
And then we got to get coefficient too, right? It would be static, actually. Do you understand? I mean, static only because it's not. This block is not sliding along this block.
But does that matter though?
Huh?
Does that matter?
Well, I'm not going to ask you on the test, but I mean, technically, you should know it's static and not kinetic. Just because it's not sliding, even though it's moving, it's still not sliding in respect to 9.
Wait, I mean, like we're finding the coefficient of friction doesn't matter though. If it's static or kinetic.
In this problem, no, because it says it's going to slide with the 9, so no, you're fine. .204, something like that.
Yep.
The F of 2 on the 9. Okay. Well, the horizontal or vertical.
Vertical.
Okay, the vertical.
Oh, yeah, I get the vertical. I just don't know.
Okay, do you get the vertical?
Wouldn't it be 4?
Not vertical. It'd be 2 times 9.8 going down,
Oh yeah.
and the other one pushes back up the same, right? Yeah. Now to do the horizontal, all you're going to do is do this. You know it's accelerating this way, so you know this is going to be 2 times 2, right? Which is equal to 4 kilograms times meters per second, right? Or 4 newtons, right? Everybody agree with that? So now, what force do you have? The only thing you have is friction. So this would be the frictional force of 9 onto the 2. That makes sense?
Is the friction also on non-negative?
The friction 9 makes the friction of 9 onto 2 would be 4 to the right. The friction of 2 on the 9 would be 4 to the other way.
Why is friction going that way?
Because what's making the 2? I'm drawing the free body diagram of the 2. So let me finish the 2. Remember, which way is it accelerate? If it's accelerating right, friction has to go to the right. There's no other force there to make it go to the right. Right? 'Cause you just can't magically go right unless there's something making it go right. And the only thing that makes it go right is that force right there. Do we feel good about this problem? On the friction here, why it goes right, you mean? Okay. Which way is 2 accelerating? To the right, right? So what force makes it accelerate? What's that? The frictional force of 9 on 2. So it has to go to the right. I mean, if it went to the left, the object's going to accelerate to the left. What's that? Say that one more time, sorry. Yes, I think yes. Are you okay with that? Okay, yes.
So, for a free body diagram with a 9 kilogram block, what is the force of the 2 kilogram block? aka friction? How much weight on it? Pushing to the left?
Yeah.
It would be a force pair.
It would be a force pair.
So, how would that have the acceleration of forces? Wouldn't that be 12 with full force of 9 on 6?
Let's see here.
Because technically, the 2 kilogram block is still slowing it down.
Dr. Holt, can we get our phones out to take a picture of the problem?
Yeah, you can take a picture problem. Let's say you're saying
Oh, we got to solve for that.
let's see.
Can you scroll up for a second?
Scroll up for a second? Yeah.
Well, to get the question.
Oh, sure, sure.
How was that?
No, the friction. You're right, absolutely. But watch what happens if you don't. I'll show you why. I'll show you why it works. So now, don't you agree? The frictional force is going to go back this way here, right? Okay. So we'll make. I prove to you this is right. This goes 4 newtons this way. Do you agree with that? Okay. Now, what do we got pushing the 9? This will be the force that the 5 is pushing the 9, right? This is the force the 6 is pushing the 9, right? 6 pushing the 9 is 12. 34. What's minus 4? Oops. So minus 4 minus 12 plus 34 must equal to 9 times A. Do you agree with that? So that's minus 16. That gives me 18. 18 is equal to 9A. A is equal to 2. Yeah. Good question. Very good question. Okay, good with that one. Okay, this one has, now how's this going to change? Now you got a force coming in at an angle, and you got kinetic friction. I'm sorry, what's that?
I'm going to tell Owen and Catherine that you said the test is going to be super.
It's not easy. I mean,
It's not easy.
He is saying that well.
Yeah.
Thank you, Dr. Cole.
Tiana is so
Dr. Cole, you still want us to find the fourth of 5 on 9 and all that junk?
yeah, that's why I said determine all force pairs. Yeah.
She is too nice. She's so soft.
Who's too nice? What?
How do you do the quick thing with this one?
What's that now?
How do you do the thing where you find acceleration with this?
Okay. Now this,
You have to break these 2 minutes first.
you're going to have to draw free body diagrams of these. I mean, I could do it faster, but I probably would confuse you if I told you how to do it. But I'll.
Yeah, you probably would.
the forces come in. I know the one on the side would be 24.5, but there's like a force going there.
Yeah, so let's do, we'll take 58 times the cosine of 25.
52.56.
Okay, so that gives you 52.5, I'll say 57, is that okay?
Yes.
Okay, 58 times the sine 25.
24.5.
Okay, so now you got 24.51.
Is this a diagram on the 5?
5 times 9.8,
49.
49. Okay, I'm missing one force. I'll have to add it back in just a second. This will be the force, the 9 onto the 5, and then we have friction going this way.
Oh.
Now, okay, so there's your free body diagram, including mass times acceleration.
The normal force is 73.51.
Is that what it is? Okay, so I would sum my force in the y first and set that equals 0 because we know it's not accelerating.
And then the friction is 7.
Not in the y direction. It's not going to go through the ground.
Friction is 7.351.
Okay, 7.5.
7.351.
Is the number force 49?
So the normal force is not 49. The normal force is 49 plus 24.51. 73.51. Does everybody see right? That's critical.
Yeah.
So then friction would equal to 73.51 times 0.10, which gives you 7.351. So that's where I got friction right here. Everybody following? The first block's hard, the rest of them are easy.
Well, you'd assume once you find the acceleration.
Okay, everybody good with that? So now let me move down and give you some space. I'm just doing one of them right now. I'm going to move this down if I can. I mean, it can be done together. It's just a little harder to do it. If I was doing it by myself, I would do it. I would do it the short way. But that's just me.
Is that more complicated for us to learn?
Coefficient of friction 0.1. All right, so let's write our first equation.
Wait, is there any downward force on any of the other blocks?
Yeah.
There is? How do you
Well,
get that?
mass times gravity.
I mean, like.
Oh, no other
from
ones.
From
No,
the original
no.
force. Okay.
So our first equation, negative 0.7351, plus the force of 9 onto 5, plus 52.7, 52.5. Okay, so,
You wrote that, so you didn't say it.
oh, thank you. 5 times A, right? Okay, so let's simplify that. Uh-huh.
Do you have like a calculator to borrow or something? Because mine just died.
I'm
borrowing it.
I don't think I do have an extra one. You can use the little ones over there. They don't. I don't know if they do trig or not. Did your battery just die?
Oh, yeah.
They don't do trade. They don't do trade.
All acid.
So there's your good equation. There's your first valid equation. Does everybody agree with that? Okay, now let's do this. Yeah. Did I mess up? I'm sorry. Thank you. How about that? That better? All right. Now let's do the next one. Scroll down, give myself some space, and keep moving this thing down as we go along. So now we're going to do a free body diagram of the 9. 88.2 going down. Oops, sorry. $88 point what?
88. So the friction be 8.82.
Okay, does everybody agree with that? That's your free body diagram. Next one.
We're gonna write the equation.
Yeah. Now the equation. Did everybody go with that one? Okay, last free body diagram. Did everybody get this one written down okay?
Yes.
Okay. We'll do this 6.
Can you scroll up just a little bit for a second?
Okay, we're good with that one. Okay. So I'll write the equation for it. Okay. Everybody see I got that one?
Yeah.
All right, I'm going to try to grab the rest of these and try to clone them down if I can. All right. So everybody go with that. So let's start solving. So now you need a strategy of how you're going to solve.
Elimination works really well.
You want to do elimination?
Yeah, it works perfectly for this one.
Okay, let's... Emily wants to do elimination. That's fine. And I got this one, right? We can use it. Oops. Does everybody follow what I'm doing there? So I'm gonna lose these, right? So now what are you gonna get? You're gonna get 5.88.
Yeah, I got 1.52.
That gives you negative 14.7, right? Yeah, you certainly can. And you don't have to do it this way. Okay, so now I'm down to this equation and this equation, right? So now can I now put those together? Bring this one right down here. Does everybody agree with that?
You just do all three equations in one at work.
You certainly could. Certainly could. Now you got 14.7. That gives you 30.519 is equal to 28, right? Acceleration 1.53 roughly.
Yes.
Good job.
I got 1.525.
I got 1.5259.
Yeah.
Oh yeah. All right, I'll go 526. I'll go 526.
That's all I got though.
What is that?
Dr. Hole, if I would put 1.5.
Oh no, you're fine. You're fine. All right. So now let's see what that means. So I'll multiply that by 5. I will subtract. All right. So I got F9/5, which is equal to F5/9. Did you get 37.589?
Yeah.
Okay, and then we'll do 9/6. 6 times 1.526 plus 5.88. Did you get 15.036? Did anybody get that? 9/6, which is equal to F6/9. 15.036. Guys, go to that one. All right, so everybody feeling pretty good? Not bad? Questions, comments? Good to go? Okay. Next problem. Where do you want me to tell me when you want to stop? I moved the problem down though as I went along.
That would be easy now.
Does it have the masses?
It has masses right here.
Can you just write down U as point 1, please?
Right here in the picture, you mean?
Yeah, so
All right, next problem. So there is a problem on a test like this. It's not quite this complicated, but you're going to have a force and an angle.
Wait, what?
There is a problem like this on the test where you have a force and an angle.
It's going to be exactly like this.
It's like this, but simpler than this. Simple. I think it's easier, probably a little easier than this. I think you have less boxes. Yeah, yeah.
Based on like this question, like compare like the other questions on the test, will they be like easier and more difficult?
I would say most of them are going to be easier than this one.
Wait,
I would think. I mean, I would call this easy. I mean, some of these problems you've never seen, like this one.
No.
You can do the problem. It looks hard, but it's not hard.
No, it's hard.
Think it through. Think it through.
I prefer the simple one.
How does that happen in life?
Could definitely happen.
what happened in life? Something hanging from the ceiling, you have something on a chair.
On top of one.
Being attached.
I mean, nothing's accelerating here. This isn't that hard. There's nothing moving.
Maybe there's a hole in
You're just lowering into a hole ground?
Yeah. Maybe
You're
it's
just like hanging it from a hole ground?
Maybe it's top.
Well, there's no acceleration. You should totally make a problem like this with Tom. Can you put that on the test?
Sorry, do what now?
Can you put a problem like this on the test?
There is a problem like this on the
Make it a
test.
coffin?
A coffin?
That wasn't there.
Wait, so Dr. Are we going to have to put tension up in the
Components, yeah. Yeah.
Wait, what level problem is this?
What level? What do you mean?
Yeah, like, would most experts be doing this? Like,
Well, what now?
would like PhD be doing this? Oh.
Maybe.
And acceleration is.
They might. Yeah, I mean, a senior level would do this. It's a high school level problem, but I mean, you can see it in college, but it's considered fairly, yeah. There's like one problem like that. I mean, I'll be honest with you, the problem on the test is almost identical to this. Different masses, different angle, but other than
Make
that.
it the exact same.
It's exactly, yeah.
Because there's no acceleration, you can easily find tension.
Yes. Tension's real easy. Just
Well, then this is really easy.
yeah, it is easy.
Wait, on the test is there no acceleration?
No.
Oh. Wait, yes. Look, Roger. Is tension equal to this?
I don't know. My heartbeat. I mean,
If that is your heartbeat, you need to get some things checked out.
what's that now?
So if we're trying to keep it from sliding so there's no acceleration, so it's equal to 0.
What's equal to 0?
Like when you're setting it for force.
Yeah, everything's equal to 0. Absolutely. Yeah.
Wait, so Dr. Holt,
Yeah.
where's the tension going to be?
Well, there'd be tension here.
I mean friction. Sorry.
Oh, friction. Well, this object, this has two components. It has a component trying to pull it up, and a component trying to pull it to the left, right?
Oh yeah.
So friction has to go back the other way. Friction's going to point back this way.
So bad at breathing.
Now, does everyone understand that the tension is just going to be 29.4 newtons, right?
So there is not.
Yeah.
The tension is just 29.4 newtons. Nothing's moving.
Oh, yeah, never mind. We're good. Dr. Holmes,
Mm-hmm.
do you know what the coefficient is?
No, I have not worked it.
So static.
So again, good free body diagram and your problem will fall apart.
Every time you say that, I keep thinking of that black hole video we saw. It was like, physics just falls apart.
I don't remember that at
I
all.
wonder if they'll ever find like the
I'm going to label the value and see if you agree with this.
So where would the cosine and sine come in for this?
You're going to have to use it. One of the forces here is going to be 15.58.
Oh, the tension. Never mind. I did not get that.
No, we have to find it. No, I have to. Yeah, I'm just drawing it right here.
I want to say yes.
Yeah, no.
I want to say yes. I'm not sure if you would say.
What? Excellent.
If you play it,
Does everyone see where I got those values?
Yeah.
I was looking down.
I got 0.397 roughly.
Yeah.
Yeah, 0.397. And your frictional force is just...
The frictional force is this value right here.
Is there going to be something like that, Dr. Hall?
Yeah, it's exactly a question like this. Exactly like this.
Exactly like that.
I think the only difference are different masses and different angle
Wait, so there's no acceleration at all?
on this problem, on the test, yeah.
On the test, is it test? Is it test?
Clicker test, clicker test.
We have the whole period Monday.
Yeah, you'll be on comment. What's that?
Whole time Monday.
Yeah, I'm going to give you the whole time Monday.
Should you be able to finish it all?
I think so. I don't think you have any trouble, Robert. Yep. Come back. Everybody good? Okay, next problem.
Oh, no. What's up with that big box?
Nina, like... Oh, no.
There's another real easy one. Easy one.
Wait, I have a question. What's up with the big box?
It's just not a, I mean, it's just some surface to me.
A surface, a random surface.
Can't draw a box.
Dr. Hall. No, what is it?
Robert, you're going to get ready in 3 seconds.
Don't be like that.
My, like, other people
Right?
Don't be like that. Don't be like that.
Dr. Hall, the tension is the same then. Like it's the same tension. Like the math test was fully right.
Yeah, it's mass. Yeah, the tension here and here are the same. Yeah. No. I can put one on yours if you'd like me to. I can do it.
Will there any be ropes with mass?
I don't think so. I don't think there is one. I can't think of. I put one on there. No, they're really not. No.
Wait, what's not bad?
Ropes that have masses.
I want to do that.
There's not one on there.
It's not there?
No.
Well, no, rope has matches. You have to put in consideration. It's like it's kinetic friction or something.
Can you draw a force diagram for the one you don't know? Or not?
You can, yeah. I mean, you got to leave stuff out. Yeah, I would. I'd draw a force diagram for both.
Are these all questions on the test?
There's some of them I won't cover. There's one that's kind of nasty that I probably won't cover.
No,
Yeah, I mean, you've done everything. Everything you've done, you have the skills to solve it. It's not unusual.
Dr. Holt, just go ahead and cover it. It's fine.
Is this one really nasty one?
Well, I mean, I'll draw you a picture with the nasty problem. I mean, I don't think it's nasty. It's just be like problem like this. It's going to have ropes here, ropes here, ropes here. It's going to have some force going this way, some force going this way, and I'm going to ask you, what is the tension like right there? Yeah, it's like the UT problem.
I don't think I ever
What's that?
That's on the test.
Yeah, there's a problem like this on the test. No mass in the ropes. Huh? If I find time. I don't know if we made around time. But I promise it's not hard. Do it just like you've been doing them. You're doing great. Yeah. That's all it is. No, it's not. No.
I don't think I got those. I was like three that. One that I know is three that two that were negative to it. I'm this making me angry. I'm like,
I got 10.4. Oh yeah, there's
I want the one.
block the acceleration is not
Now, I'll be honest with you. There's never been a freshman physics class that's could ever solve these before you guys. You're the first students that have the ability to do this.
This is the loophole. This is actually not that bad.
They said that last year it was hard because
They never did problems this hard last year.
They came in like the first day and they had to like solve some big problem. They were talking about being in the rail class. He was like, "Yeah, here's a lecture.
Wait, Dr.
Day
Nate.
one, do this."
Which, is there any negative? Oh, yeah, there is. I get it. No matter. I get it.
Dr. Holt, what's tension?
And I'll figure it out real quick. All right. So let's do friction first. So let's draw a free body diagram real quick.
They're both negative, aren't they, Robert?
Hold up.
The acceleration.
I'm going to leave these off here. Is that okay?
Wait, Dr. Holt?
Yeah.
Would the acceleration be negative on the 6 kilogram block?
Yeah. I would.
On both of them, right? Oh, no, only.
No, only on this one.
Why only on that one?
Because tension is going to go up on this one.
That's not acceleration, though.
No, acceleration go down.
Is acceleration negative?
It will be on this. Here, watch this. See if you agree with that.
Yes.
So tension was 25.06, right? Does everybody in class see how I got that? Because all I'm doing is this. Summation forces in the x equal mass times acceleration in the x. You guys good with that?
Yes.
Okay. Next free body diagram. Draw one of this and you're done.
I drew it. I'm not drawing.
Negative 9.8 plus 25.06.
I love MMOs. Yeah.
Does everybody see how I got that? Everybody go to that. All we got to do is solve that and we're done.
Wait, why's accelerating down? Wait, why's it accelerating down?
Because the whole system's going this way.
Did you get
3.685.
Yep. The mass.
She gets 3.685.
Dr. Holt.
Yeah. What's that?
Four little things.
Well, there's a question like this in the exam. Yeah.
Yeah, but do that other one that you were talking about, the real nasty one.
All right, well, I'll try to get time. I don't think we'll have time, though. Everybody good with that one?
Yes. Dr. Holt, post a video on Dr. Holt, post a video on the
You may have to bug me about it. I'll try to do it tomorrow sometime.
Dr. Holt, I will spam the video.
I got some.
Oh, yeah.
Went down.
Dr. Holt.
Yeah.
I will spam your email until you put up a video. It'll be on the active
All right. Well, I'm gonna be busy tomorrow until about. I'll get it in there probably tomorrow night sometime.
Alrighty, well then I'll spam your email.
Huh? I might make one video either Saturday night or Sunday morning early. So. What's that now? Sorry, what's that? Yeah, but I'll probably get around the time today. If I do, I'll post it. I'll make a video of it.
Do one of those, Dr. Holt. Dr. Holt.
Wait, how about
What's that?
That's one of the ones where you have the two different tensions, like you have to block them, but you have 3 different blocks.
I don't think I have one like that though. I'm trying to do problems like on the test. Now this is an easy problem. There's no acceleration. Yeah, there's a problem like this. Sure you do. Free body diagrams each one. They got to equal 0. Not moving.
Wait, Dr. Holt, what is it? Dr. Holt.
Yeah.
This seems really...
It is easy. And the one on the test easier than this one.
No, this seems too easy.
Yeah.
You need to do it separate. Dr. Holt, this seems too easy. What's the trick?
Robert? Not too easy.
What's the trick?
It's not a trick.
What's the trick?
I disagree, Robert.
It's very simple.
Now everybody know you can find T3 just like that, right? 2 times 9.8 and you're done.
Yeah, that's what
So 19.6.
Dr. Holt, is that one of the questions?
Yeah, it's the question on the test even easier than this one though.
It's only 2 balls.
Yeah. Now there's going to be some there's like 2 or 3 conceptual problems on the test. Don't let them fool you. Conceptual. I mean, think about it again. The thing where the bug pushes on a semi with 5 newtons, the semi pushes back on the bug 5 newtons. Just keep that in your mind. I mean, it's that type of easy stuff. Just don't fall for it.
No, but it's stuff that gets
You're
you.
going to one for the 11th, and so you'd have like force of gravity going down, and then T2 going up, and then where would T3 be? Would it be going down or going up?
Well, here I'll show you. What was T3 real quick?
19.6.
19.6. Okay, so now free body of this one. So what you do first, you're going to have 2 forces coming down. You're going to have 19.6 coming down, and you're going to have 11 times 9.8 coming down. And then you're going to have T2 going up.
T2 has to be equivalent to all those.
Yes. So all you're doing is summation of forces in the y direction is equal to 0 because acceleration is equal to 0. Oh, I went. Did I go forward? Oh, I'm sorry. I'm sorry. I hit the button. This is this problem here. Let me grab this stuff. Let me cut this. Sorry, I hit the button. Let me go back.
Dr. Holt, is a question like that next one going to be on the time?
No, I was going to do it if we got time, but
And you would get 180.
No, but Dr. Holt, the next question on the next screen.
it's not going to be on test. I was going to work it if we got time.
Some places, sometimes you can choose. You have
So everybody get this? 127.4, right? And then the last one.
I'm sorry,
Focus, focus, focus.
186.2.
Okay, 186.2, right?
Yeah, 127.4.
Okay, so we got the values, right? This one, and then again T3 was just 19.6, right?
Right.
Basically, you work the problem backwards.
Yeah. Good to go with that.
Yeah.
Okay, the next problem is not on the test, but I was going to work if we got time.
Is this the last one working?
This one, there's going to be an extra credit problem like this.
Oh no, that's not too hard.
No, it's not very hard.
This is hard.
It is not hard.
What's that? No. Different masses, different angles. That's it.
How much is that worth?
3%.
An extra 3%. No, but it's not worth it.
It's worth doing. I mean,
It's not worth the effort.
Wait, can you make it one question?
what?
Is that one question?
One question worth 3%.
How about make it worth 10%?
How about make it worth?
I'm going to give you an
100%?
extra. I think I'm going to give you an extra 3 just because that thing we did.
What?
I think I'm going to give you an extra 3% anyway because we did that activity and then it snowed and we didn't get to finish it.
Yeah, we never did. Yeah,
I think I'm just going to give everyone 3%.
Thank you.
I'm okay with 3%.
What?
Stop freaking complaining.
Everybody's going to get 3%, and if you get this one, you get another 3%.
Okay.
I'm fine with that. And if everyone has to what do you know?
I probably won't get.
3% is almost making up for one problem.
Yeah, I want you guys to do well in this.
Do you?
Yeah.
Dr. Hole.
Actually, a question is worth 4.3478.
Is it?
You didn't say it was worth a question.
No, he said it was worth about a
I
question.
said it was worth almost.
Well, it should be worth
No, what?
God.
You should make it worth one.
Yes, worth 1.5.
You're okay. You're okay.
Then it gets all messed up.
Wait, did you
That's cool, but that's not worth the effort.
Typically, it's like you get extra credits. Like, okay, it's not
Also,
fair.
last one, third option, you get 1%. Oh man, no 1% is going to bring up 3%.
I don't know. It could. Like,
It can make the difference between a B and a C or a D and an
you're
F.
like 189.
Does everybody know how to do this problem, I hope?
No.
No? Draw yourself a good free by diagram first.
No, 49 will make free. Okay, yeah.
Is it like this?
So this angle here is 42 degrees.
Wait, so if we all do this, you get to class and
Is there any friction?
No, there's going to be a problem like this on the test, though. I'm just saying.
Is there going to be friction?
I don't think so.
Oh, well, that's super easy.
I know. I'm being nice to you. Too nice to you.
It's not super easy. Like this almost.
No, Dr. Holt, you're making up for all the times that you've laughed at me.
You need to think that episode about
Because Dr. Holt.
Oh, I love you, Robert. You know that.
Yeah, that's why you laugh at me and make fun all the time.
I know, right? Everyone be trying to talk about stuff.
I know this is really easy.
Alright, who died?
Okay. We go walk slow.
Hey, what are you talking about? You just find somebody else and make them
My
idea.
dad's picking me up, so I don't have to ride the bus.
You can probably find similar boys. Or you can get computerized.
This is too grassy.
Yeah? Did I make a mistake?
For the 3 kilogram, which one is your original vector?
The dotted has to go straight down.
Got it.
Okay, everybody go with that so far?
Is there friction on this?
There's not going to be friction on this one. Now, everybody understands this object's obviously going to accelerate this way, right? Because this force here is greater than this force here. Right? You don't have to even worry about the normal because there's no friction right now, right? All right, now, if you wanted to, you can get the acceleration immediately from this system by doing this. Summation of forces must equal to mass times acceleration. And you could do it this way. Minus 19.67 plus 69.5 must equal to 12 times A. Right? That's the only forces you have pulling this thing. I'm just showing you an easy way to do this problem.
It must equal 12 times acceleration.
Dr. Cole, that makes it so much easier.
Yeah, this makes it really easy.
Doc told us this earlier.
Because I like your math skills to get better. Does everybody see how I got that value?
What? Yeah. Yeah.
What's that? Sorry. Now, to do tension, you can pick one. Doesn't matter which one you pick. So I'm going to pick the 9. Yeah?
For the 9 kilogram, it's 69.5. That's the right gravitational force.
Yes. 88.2 times sine of 52. Did I mess up? Okay. All right. Okay. You're fine. Yeah, go ahead. All right. Focus. 69.5, right? There's your tension. There's your normal. And then we could call this 54.3 if you want to.
Which one? Is this for the 3?
I'm doing the 9. This is the 9 kilogram. Now, off to the side. We're just about done. Focus. Off to the side, guys. All we have to do is put 9 times A. And again, it makes no difference which one you make negative. What do you want to do? You want down to be negative?
Yes.
Okay. T minus 69.5 must equal to minus 9 times 4.153.
Well, why would we make that one negative?
Because they're both going down. The acceleration is accelerating downward. This is going down, so they're both negative. Is that okay?
Yeah.
Dr. Cole, you should make the extra time work.
I got 32.13. Did everybody get that?
Yes. Is that it?
That's it.
And this is the extra credit problem?
That's the extra credit problem.
I'm supposed to miss it.
Huh?
That's the extra credit problem. You are very generous.
I'm being generous this time.
Thank you.
I want you to do well. But still, I wouldn't call it an easy test. There's still some conceptual problems and.
Complicated conceptual problems, or are they all like...
You gotta think about it. But just think about this. If a bug, what you don't want to do is think if the bug hits the semi, they both have the same acceleration. Don't get caught into that stuff.
I get caught in that stuff.
Huh?
I get caught in that stuff.
Wait, so what should we think?
Well, you can say the forces are the same, but they're going to have different accelerations.
Why are the forces the same?
Because Newton's third law, for every force equal and opposite force. So, what's that?
Acceleration is different.
Acceleration different. All right. Close this.
Are we done?
We are done. Just don't go crazy for 5 minutes, okay?
Dr. Cole.
That was an hour.